lecture we are discussing about the surface chemistry. So the surface chemistry, already we have discussed a lot of concepts within this chapter, the absorption and many things, right? So now in the surface chemistry, now we are going to deal with the two adsorption isotherms. I have already explained you what are the adsorption isotherms. I have already explained you. Basically, adsorption isotherm is a graph. Basically, it is the graph where we are. It is the graph representing the amount of substance adsorbed with respect to the pressure at a constant temperature. So, iso means what? Constant. And therm means what? Heat, energy or temperature. So, it is the graph which is plotted, plotted for amount of substance adsorbed. This is represented by x by m, which already we have discussed in the previous lecture. So x by m against varying pressure, that is P. So students, यहाँ पे हम सिंपल सी चीज है, एक ग्राफ बनाएंगे. इसके लिए आप देख रहे हैं कि ये कुछ ऐसा होगा मेरा ग्राफ. एक साइड y एक्सिस, दिस इज योर x एक्सिस, दिस इज योर y एक्सिस. y एक्सिस पे मैं दिखा सकता हूँ अमाउंट ऑफ एब्जॉर्ब्ड, दिस इज x by m, which is increasing from this zero, this origin to toward the arrow, and from origin toward the arrow the pressure is increasing. So if you draw for adsorption over here, adsorption of gases, let me tell you in your chapter only the adsorption of gases on solid, this is being discussed actually. So adsorption of substances, the graph will be like coming like this actually. So here the two theories we have to study. The first is Freundlich adsorption isotherm. Freundlich adsorption isotherm. And what is the name of another isotherm which we discussed? The one is Freundlich adsorption isotherm and other is Langmuir adsorption isotherm. So Langmuir adsorption isotherm. So all first we are going to discuss about the Freundlich adsorption isotherm. It is a very simple. Basically, Freundlich have done the, it was having an empirical approach. And Freundlich has given an equation, and he said the amount of substance, that is x by m, is directly proportional to the pressure to the power 1 by n, Now let me tell you students, this is your amount of substance. If I want to remove this sign of proportionality, so I need to add some constant over there, right or not? So this x by m is equals to Kp to the power 1 by n. Let me tell you, these both things, values 1 by n and the k are the constant. and the value of 1 by n and k depends on the nature of gas which is being absorbed. So the value of these constant depends on nature of gas absorbed. Nature of gas absorbed. Now what Freundlich has done, he has divided this graph into the three regions. The first region you can consider as the lower region. It should be from here. I'm making mistake a little bit. Lower pressure region you can see. This is the moderate pressure region and this is the high pressure region. This is the low pressure region. This is moderate pressure region. Moderate, and this is high pressure region. Getting my point, students? Getting my point? Now the condition is only the value of this P would be changing. So there are three conditions will be given to us in the Freundlich adsorption isotherm. In the Freundlich adsorption isotherm, x by m is directly proportional to pressure to the power 1 by n. X by m is equals to k p to the power n 1 by n. Now all first what Freundlich has done, he have considered this 1 by n, or here you can say no, this pressure is in the low pressure area. So what he deduced for low pressure area, in the low pressure he said P is 0, means pressure will be very less. Pressure is very
less.
The value of 1 by n we are changing. The value of 1 by n we are changing. So in the low pressure region, the n value will be 1. The value of n will be
1.
N is equals to 1. So if n is equals to n, we can simply write x by m is equals to this k p 1 by 1. Means it is nothing but 1 only. Nothing but this 1 get cancelled, no? So x by m equals to kp. Right or not? Right or not? This equation leads to a straight line passing through the origin. So the graph is justified, as you can see, in the lower region. Right? Now when we are moving in the moderate region, the value of n would be in between 0 to 1. The value of this n would be 0. It is
1 by n.
lesser than 1, but it is greater than, see, lesser than 1 but greater than
0.
So simple, the value will come as it is x by m equals to kp 1 by n. So this line, this kind of equation present or represent, we can say, the curved graph. So this also gets satisfied, right or not? Now do you want me to rub the upper portion? Can I rub it?
Yeah.
Okay. So now see, in the last high pressure region, now the value of n in the high pressure region, the value of n will become what? 0. If the value of n has become 0, so students, let me know kp 1 upon 0. What is the value of 1 upon 0? Infinity. So x by m equals to kp, it will become infinity. And as we know, for any gas, the value of n cannot be 0. It will, now the pressure is leading toward infinity. You increase the pressure, but because here you can see, no, even though you are increasing the pressure constantly, but there is no increase in the amount of adsorption. Getting my point? So here this equation become fail. This equation become fail, and they could not explain. This could not explain the high region of the adsorption of, or you can say the adsorption in the high region of the pressure.